What's up guys, welcome to today's show. So today we're gonna learn about inverters, and it is what it sounds like. The symbol looks like this. So we have an A input and a Y output, and this little bubble here indicates that this is an inverted output. And other symbols include that too, if the output is inverted. So if we look at this truth table here, so if the A input is a 0, we get a 1 as an output. And if the input's a 1, we get a 0. But how do we construct such a thing? When I want to learn stuff like this, because you have all the base knowledge if you have watched this series, then you know about transistors and resistors, and you know how the electricity flows. So if you were to pause the video and try to design such a sketch on your own, so that's what I did. And then I needed to modify it a couple of times until the logic pans out. So you can try that if you want. I will start to write down the design that I came up with. I haven't yet tried this one or looked it up in any way, but I think it's going to work. So if we start with the plus side of the power source, so here we have plus 3.3 volts, let's say, and then we have a transistor connected something like this. And on the middle leg we have the A input. And then we connect this to a resistor, a very weak resistor. I'm thinking something like, I don't know, 82 ohms. And then we connect this to ground, like so. And in parallel with this transistor, I'm gonna do something like this. So here, let me see here. So here I'm going to have another resistor. Something like this. And here I'm also going to connect to ground. And in parallel with this, I'm going to have the Y output. So my thought is like this. If there's a 0 on this A, so there's no electricity, that means that this transistor will be offline, so nothing will flow through this here. Which means the electricity will take this way instead and go into ground. And this will give a logical 1 on the Y output. That's the thought process. And then if this A is a 1, we will activate this resistor, because there will be electricity flowing like this here. which means if we start from the plus side of the battery, it would go through here. And since this is a very weak resistor, and this is a strong one, so this is, let's say, 1000 ohms, which means that the electricity will pick this direction instead of this, and this Y will be a logical 0. It all sounds very logical, right? So let's see if we can build this thing. We'll be right back after this. Alright, so let's start by connecting the plus side using one of these jumpers. So something like this. And then we take a transistor, an NPN type transistor, and we connect the first leg in a manner like this. So it's connected in series with the plus side. And let's see, what did we do then? We took one of these weak resistors. So I think this is the correct one. If it's not, we need to switch later on. Because I haven't yet learned how to interpret the colors on these things. Okay, so that's that. And what did we do then? We connected it directly to ground, right? So let's do that. So in series with this resistor, we make a connection to ground. This. Okay, so this is the first path, so to say. What else? Okay, so now we need to take the other path, which needs to be in parallel with the one leg of this transistor. So let's do something like this. I will connect it over to this side here, like so. And what did we do then? Here we're going to have the output. So let's connect this LED light. I need to check which is the longer leg. So you take the longer leg and connect it to the plus side, which is this jumper here. So the other side can go directly to ground. So this light will resemble our output. Okay? And then we need to have an additional connection to ground, right? So something like this right here. Or do we really need that? Let's start like this and see where we end up. then we need to take so this is, the light here is the Y output, and now we're taking care of the input, the A. So we take the middle leg of this transistor, and this jumper cable will resemble the A input. So let's start by connecting it to the plus side, which means it's a logical 1, and this light should not light up since it's inverted. So let's see what happens. I'm gonna connect this power source like so. Okay, it does light up. Why does it do that? Maybe this transistor, let's see here. No, we need to have this connected a little bit differently, because it needs to have a longer route on this side. So let's take this hopefully bigger resistor and connect it in series instead. Then we take this light and try to align it properly, and then to ground. And let's connect this to a logical 1, and hopefully this light will not light up this time. Okay, that's good. What if we were to connect this to a logical 0? Now it should light up. It doesn't, however. So this route here should be, yeah, I don't think we need to have a resistor here. Let's just connect this directly instead. So this should go to ground through the right leg of this one right here. Okay, so this time it should light up if everything works. But it doesn't. Why not? This goes from plus and then over here and to this right here and here. What if we activate this? Will it make a difference? No. We go from plus, we go here, we go over here, and we go here, and over there. And this is the plus side. What if we were to change this to the other one? something like this. And let's add some power. Okay, so now it lights up. What if we were to send a logical 1 instead? This time it should not light up. And it doesn't. Great, we have successfully created and designed an inverter. That's pretty cool. So now when we can invert these kind of things, we can create stuff like a NAND gate. And we'll be right back after this. Okay, welcome back. So this chip right here is a 74LS08, which contains 4 AND gates. So let's take this chip and connect it right here. And let's start by connecting power and ground. So as we can see, the power should go here at port number 14 on the top here. So that should be right here. So I'm going to connect this to the power input, like so. And then we need to provide ground. And as we can see here on the data sheet, it should be the port on the lower left right here. So this is the right row. And I will connect this directly to ground. Alright, and then we need to connect the inputs. So let's see here. Let's start with the output, the Y here, on port number 3. And I want to take this inverter and connect it to the Y output. So it's the third one here. So let's see. 1, 2, 3, or something like this. And let me get one cable. Okay, so let's connect these 2 jumper cables to the 2 inputs of this AND gate. so. And let's start by connecting both of these to the plus side. So now our complete NAND gate has the two inputs as one, which should not let this thing light up. Let's see what happens when we apply some power. It does light up though. Let's see, we have 1, 1. And if both are 1, it should be 1, and then it should be inverted. What happens when we change something here? It lights up anyway, no matter what we do with these inputs. That's a little bit weird, no? Did I misconnect it somewhere? Let's see. No, it looks right. And this, oh wait, I connected the wrong end of this output cable. This should be connected to the middle leg. I changed the wrong end of this one. Phew. Let's start over. So now we go in with a 1, 1, which should result in a logical 0 in this case. Let's see what happens when we apply power. It does light up a little, right? Yeah, I think it does. What if we send 0, 0? Okay, so now it lights up properly. And if we send a 0, 1, it lights up. And if we provide a 1, 0, it lights up. And if we provide 1, 1, it doesn't light up. So, ladies and gentlemen, we have successfully created a NAND gate, a rather complicated circuit. And with a NAND gate, we can do beautiful things. I will show you. So, we'll be right back after this. Alright, welcome back. Now we're going to talk a little bit about a NAND gate. So here I have shown how a regular AND gate works. So if both inputs are 1, then the outputs are 1, otherwise 0, as we have learned before. And this is the symbol of a regular AND gate. But if we were to take this output and connect it through one of the inverters that we just made, then this output here will be inverted. So if both are 0, or we have a 1 and a 0, or a 0 and a 1, in that case the output will be a 1. And if both are 1, then the output is 0. And a NAND gate has its own symbol, which looks something like this. So it looks like an AND gate, but with this little bubble here, which indicates that this output is inverted. And with a NAND gate, we can do pretty interesting kinds of logic. And let's see if we can build this thing. We'll be right back after this. Alright guys, so this far I have been using these batteries for powering up all my projects. So these are two 1.5 volt batteries, or 1.6 really. So it gives around 3.3 volts, but many of my chips requires 5 volts. So I'm gonna try to do something. USB cable. So what I'm thinking is I'm gonna cut this one and connect it to a power adapter like this. A regular iPhone USB charger. Or not iPhone, but a regular USB charger. And I also want to connect it to this one. So this is just like a regular power switch, but it has one of these USB adapters and a regular USB in this end. So you can connect a regular USB cable and use this as a switch. But first I want to make it work with this cable right here. So let's see if we can figure this out. So I'm gonna start by simply cut this end off like this. And I wonder if I can use my regular wire stripper. That's the one. So let's see here if it fits somewhere. Maybe I can use this right here. So let's take a big bite of this one. No, I'll try the next one. No, third time's the charm, right? Let's keep it going. This might work. Ah, it would be like this. Okay, so this foil here is part of the ground, and it's being used for isolation, so it will not be a lot of noise. So let's see if I can move this a little bit to the side like this, and then see if I can strip this thing right here. Or maybe I don't need to. This seems to be just some foil as well. Let's see here. Alright, so here we go. Okay, so now we need to figure out which cable is which. And we have a red and a black, which could indicate that this is the two power cables, which would make the white and the green the so-called differential pair. which is used for data transmission. So let's start with a assumed ground cable here, and let's see if my little tool can take care of this. Something like this. Huh. You look at that. And then I'm gonna strip the red one as well. And I'm not sure that these colors is what I think it is, but I'm gonna use my multimeter in order to figure that out. So let's take a big bite at this one, like so. And since this foil here is probably part of the ground, I think I'm gonna do something like this. I'm gonna take a bigger bite out of this this ground here. So let's see here. And then I'm gonna take this foil here at the end and connect it, twin it together with this assumed ground here. So I'm going to spread these a little bit, put them closer together, and then just twin these along with each other like this. And later on I'm gonna solder in some pin here. So I can connect it to the breadboard in some orderly kind of fashion. Okay, that's good enough, I think. I want to try to make this end very pointy and stable, so I can at least try it out on the breadboard. But first I'm going to use this multimeter right here and see if we can measure voltage. So I'm going to take this end and I'm going to connect it to my charger, and I'm going to connect this charger to a wall socket. Alright, let's hope this works. I'm going to put something over it so it don't go all over. And I'm going to configure this so it measures voltage. Let's try this setting. So I'm going to connect this black probe to the ground, and I'm going to connect this to this side right here. And you see? 5 volts. Very nice. It worked at the first try. That's not always. What about this one? Will this work? I'm not sure, but let's try it out. So I'm going to take this wall socket here. Then I'm going to connect the USB to this right here. I'm going to connect this and back into the wall socket. And I don't know if it's activated or not right now, but let's try. Okay, 5 volts. And then I'm going to click this button. Close to 0 volts. That is perfect. Perfect. So now I only need to add some connector to this right here. So I have some easy way of connecting it to the breadboard. So we'll be right back after this. Alright, so now I have connected these 2 pins and created a quite nice looking power cable. And I have created a very simple, maybe I should turn on the lights. A very simple circuit here with just an LED light connected through a resistor to ground. So let's see if this works. So first I'm going to connect this power cable here in the right way. And then I'm going to click the button and see what happens. Ha! Well, you look at that. Do you see how bright it's lighting? So now I will be able to use all my chips which require 5 volts. So thanks for watching. Thanks for today.